Verzeo. Learn here, lead anywhere. Subscribe to our Verzeo channel and tap the bell icon to receive all notifications. Download the Verzeo app and get free content access.
Hello everyone and welcome to the session today. I hope I'm audible to all. Firstly, let me introduce myself. I am Harshita from Verzeo and I'll be your host for the session today. So the topic of the webinar today is the age of data. Okay, data science is one of the most booming sectors of computer science, being one of the fastest streams of technology. Its fundamental involves using automated methods to analyze gigantic amounts of data to extract valuable information from them. Now, let me give you a brief introduction of our mentor today, Ms. Ekta Shah, who is currently working as a senior executive in data science and analytics in the company Viacom 18 Media Private Limited, which is one of the India's fastest growing entertainment network and a house of more than 3 dozen iconic brands. Now, Ms. Ekta will be sharing her knowledge regarding her expertise with you. Let's welcome her. Ms. Ekta, the stage is over to you now.
Are you able to hear me?
Yes, ma'am.
Okay, thank you so much. I'm just going to share my screen and display something so that that will help me in hearing the conversation that we are about to have. Just let me know once you guys can see my screen. Are you able to see my screen?
Yeah.
Okay, you're able to hear me and see my screen too? Okay.
Yes.
Thank you so much. So what we're going to be doing today is, as we have a designated time for the session, what we're going to be doing is, I will speak for about 35 minutes, 35 to 40 minutes per. And then what we're going to be doing is we'll do a Q&A session so that I can take up maximum questions possible. And I'll try to answer all the doubts that you have throughout, like whatever is there. The kind of policy that we'll follow is that I'd appreciate if you would just write down your questions, like tag them down in the chat box till the time of the like the webinar is over. And you can also post in questions directly during the Q&A session. You can directly ask me the questions as well. But if you have any questions during the webinar, then you can ask them through the chat window. Does that work? Works with everyone, right? So you can just type in all of the questions that you have into the chat window, and then we'll answer all of those during a certain time. Cool. And if you're not able to hear me at some point of time, something that you don't understand, we can keep it for the end. But if at any point you're not able to hear me, or if there is any other technical glitch because of which you're not able to see the screen or something, do interrupt and let me know at that time itself. Okay. So what we're going to be talking today is going to be the age of data. So according to whatever like people understand till now, data is like the new churning oil that you can see in the industry today, right? There's a lot of data that is being accumulated, being spoken about, and you'll also see a lot of information coming out only because of data. So if you even glance through your newspapers or say through Google News for that matter, you'll see a lot of articles which are talking at greater length about data. Now, what is this data that is actually fueling everything today, be it any kind of technological advancement, be it anything related to even, say, COVID, how COVID has actually progressed and how things have changed with the help of data? And what kind of inferences you can draw with the help of the kind of data that we have. So data has been like the new furnishing oil that you see that everyone is talking about some aspect of data or using some aspect of it somewhere or the other. Like it's quite evident that you see articles which talk about data day in and day out. So we'll just have a look at the agenda that we have today and we'll see what all we plan to go about today. So you'll see that this is what we are aiming to complete. That is, we'll talk about a few examples about data which is there in the world today across industries and across different applications that you see. Then we will hear like about what the exact technological term data science is and why is it so much in like the news and so much in force everywhere. Then we look at the formal applications that we have of data science. Then we'll also have a look at the process flow, that is basically the life cycle that a piece of data goes through before it becomes useful. Then we look through a simple use case, like a simple example that you will come across in solving the data science problems on a day-to-day basis. Then we'll talk about what is there for you. like totally into the data space, what all is there that you can do, and what is the kind of things that you can pursue as a career, or like even on the research side, even on the educational aspects. So those are the different things that we can talk about in the journey ahead. So the first thing that we're going to be talking about is what all data is there everywhere across the world. So it's data everywhere. So whenever you just move around your head, look towards different things, even at your house, you'll see that there are electronic devices present, right? Now, these electronic devices that you have at home are going to be generating a lot of data. They are, of course, being used by you, and whatever interactions you have with those electronic devices is what is called as data in like the simplest terms possible. So you'll see that there are a lot of shopping websites that you use on a daily basis, say Amazon, say eBay, say Flipkart, say Myntra. You've heard about all of these websites, right? Now you as a user go on to these websites to perform some transactions, to buy something, or to check out prices. Now when you're doing that, of course you do have to create some kind of an account. So basically that is your first data point which is collected as a person. That is, a lot of data is collected from your profile which is created. Then secondly, you interact with the website, like when you're like buying something or looking for, say, a mobile phone on Amazon.in, then you are having certain interactions with the website. Now these interactions that you have with Amazon.in are stored in some kind of a data at the backend. Now, this data at the backend, what I'm talking about is basically all the clickstream data that you get. So, whatever you interact with a particular website is going to generate some kind of click data. That is, you click here, you click there. So, you're in XYZ position, you click. And now that is what is going to generate like data, and that is going to be stored. When we talk about storage, so that's another sector altogether where data is being stored on multiple devices, basically multiple devices and multiple mediums too. It may be stored on servers on premises, or it may be outsourced and stored on cloud providers. Now those are like storage services which are provided to you as a person so that you can store your data on their servers. So that is just one aspect of it, where we're talking about how data is stored and how it is like basically generated and stored the entire cycle. So you'll see that there is enormous amount of data which is generated through these shopping websites. Like Amazon is a huge database. Talk about Flipkart. Flipkart also has a very, very huge database. Even Myntra. So the kind of interactions you have with the website will generate a large amount of data. Now, secondly, you'll see that there is a lot of data which is generated by social media. Now, we have a lot of social media platforms that we use on a daily basis, something like a Facebook, say Instagram, say LinkedIn, any of these. Twitter. So these are your social media websites. Now, when you create your own profile over there and you enter that particular social media platform, there will be a particular row or something that is created for you in their database at the backend. So basically, it is going to be generating data for you when you create your profile. Now, that is just the beginning. When you like interact with your profile, that is, you create multiple posts, you post pictures, you post statuses, you post various things with respect to each and every social media platform. Now all of this data is also stored somewhere in relation to your profile, so that whenever you hit a query which says that I want to have a look at my profile, then I'm able to see that. So all of this is like humongous amount of data which is stored, and now this data which is stored was just stored up to a certain limit, okay, earlier. But now what we are trying to do is, suddenly we have realized over a period of time that if we try to mine that data, or if we dig deeper into that data, we might understand and gain some importance of the entire data patterns that are being generated. So when we look at the data and try to, minimize it in the sense that you would just want to display it using some pictorial representation or some graphical representation, that will aggregate your data, but it will also try to give you some kind of an insight into what the data numbers are telling you. Now, that is one aspect about generating insights from data or generating conclusions from data in the simplest way possible. So, this is how data is basically being used as an element to generate revenue. We'll get to all of that. It's just that these are the different applications which is giving you like an overall exposure to what kind of data is generated. And if you try to imagine, you will not be able to think about the kind of size of the data which is being stored. So social media generates a large amount of data that you have. Now, next we go to travel websites. If you go to Yatra, Make My Trip, Trivago, you make so many search queries. Now they also have a lot of data with them with relation to the tourism aspect, like where you're trying to do hotel bookings, trying to do travel bookings, trying to do flight bookings. All of that generates like large amount of data. So travel websites is also a very common example where you might see a large amount of data. Next up is your supply chain industries. When you talk about supply chain industries, it means it basically refers to all the manufacturing domain industries or factories that you have. Now, if you look at any factory which is producing something, so if say I have a factory which is producing some particular plastic item, now when this factory is producing that item, it goes through several phases. Like the machine is developed in such a way that it's a series, like it's connected in series, and there is like a pipeline which is generated. So, of course, there will be a lot of data which will be generated with respect to it also. So, that's how you supply chain industries also have a lot of data. Next comes your financial institutions. So, you already know that you go to a bank, interact with your bank. How do you interact with the bank as a customer? You will open an account with them, you'll do transactions, you'll put in your money over there. You might use their services like credit card, debit card, loans, etc., etc. So those kind of services will help you to do your financial transaction. Now these banks or say insurance companies have lot of data which is aggregated over time and collected over time. So this kind of data is also very huge, and there can be a lot of things which can be done with this data to generate some kind of a conclusion with respect to it. So this is like some of like these are like very small listed applications that you see about data in the world today. So data is collected at each and every place, and we are not actually aware about the kind of data that we are generating every minute in this world. It is very large. You cannot really imagine how huge it is. So that's how this entire field came up about data science and analytics, which would really try to mine data, try to make the best use of the data that you have. Next on, we'll move to looking at what data scientists are or what data science the field is. It is often said, like you must have heard about this term or the sentence which says data scientist is the sexiest job of the 21st century. Now, this sounds very high, fancy, and sounds cool. But if you really look at what they do, you can see that in the picture over here. I'm just gonna try to minimize this so that you can look at this image. So basically, it says, oh, you're dropping your numbers. The data scientist says that no worries. I have so many of them. I'm a data scientist. So what a data scientist does is basically they try to work with data on a daily basis. Okay. So the data is going to be numbers largely, because whenever you try to get out some kind of information from your data, you will need to do some kind of an analysis or number crunching, which will help you to come up to a conclusion. So this is what largely a data scientist does as a whole in their daily lives. So this is like a quick representation of what a data scientist does on his daily day-to-day job basis. Now we'll just talk about the kind of skill sets which are usually required for getting into this data space, or what this data space is all about and what all you need to know. So there are three different bubbles that you have over here. The first one is about the computer science basics. So whatever you learn as a part of, say, your engineering or someone into BSc Computer Science or BSc IT, something similar, courses similar to that are going to be covering all the fundamentals that you have into computer science, which may be, say, networking, operating systems, data structures and algorithms. You learn about how to code as a human being, like how would you code or approach a certain problem and solve it with the help of some programming language. Like it could be anything. It could be, say, C, C++, Java, Python, R, could be any language, but you need to know the basic computer science fundamentals to get to the core of data science. So that is like one of your large bubbles over here, which are required, which is like a mandatory point in the skill sets which are required for data science. The second bubble that you have is about maths and statistics. Now, your maths and statistics covers all your basic mathematical algorithms and all your basic stats which are required for getting into this particular space. You need to know your basic stats and maths to crunch numbers. So when your day-to-day job is going to be about looking at numbers and trying to derive value from it, then you need to know the basic algorithms or the basic statistics methods which go into getting this outcome from that data. The third bubble that you have is called as the business or domain expertise. So depending on the problem that you're trying to solve, you need some kind of a domain expertise over there. Depending, like it totally depends on the kind of industry in which you're working in and what kind of problem you're solving. Now, there's an intersection of each of the skill set which you see for the three bubbles. Like when you intersect computer science and maths and statistics, it's together forms a new branch which is called as a machine learning criteria. So these are just high level buzzword terms. You don't need to pay a lot of heed to it, but you need to know that to get into the space. The second kind of intersection you see is between computer science and business or domain expertise. So that is your traditional software development. So when you say that a particular person is into a software development role, that person is going to be doing some kind of code changes and solving problems related to a particular domain. Now you have this third intersection, which is called as data analysis. So when you combine business and domain expertise along with your basic maths, you can do some kind of descriptive statistics, inferential statistics, and that will help you to get to a certain results. So when you cumulatively see at this bigger picture of the three circles intersecting together, the middle part is forming what you call as data science, the buzzword, which combines these skills all together and which you see in this entire bubble set that you have. So this is a combination of the different skills you have, and it really helps you to get into this space and how you can really develop yourself to get till you. Now the terminology. Usually we have some kind of terminology or definitions that are there, right? So it is basically defined like data science. You would define it as an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. So you have some kind of a data. So I'll just give you a very simple example. You have some Excel sheet and it has some data, say, what kind of a data we can take is student data. So I have the name of the student. I have the age, the class or the standard in which he is in, like if he is in school, and you have marks for different subjects associated with it. Now you have this kind of a data. When you are trying to extract some kind of a knowledge or a pattern from the data, that is, you try to understand, okay, what is like the performance of the students who are usually the toppers of last year. So that kind of like data analysis we're trying to do, you're trying to extract some kind of insights from data. So basically you're trying to get some basic level information out of data which will help you to make certain conclusions. So that is how you progress to data analysis and subsequently to data science, where in data science you're using much more complex algorithms in comparison to what you would do in a data analysis kind of a role. So this is like a basic knowledge extraction or insight extraction that you do from your data. Now these are like there was a term like this data scientist as a term is a very famous term which you might have heard of. And it was coined very recently, like it was coined very recently in 2008, especially when people saw that there was a huge need for, people to enter this data space and to extract information from data because there was a large data that was collected at any kind of organization level that you have. So this is the basic idea about the terminology that you have with the data science. Now we'll talk about the applications, which will give you like a better idea about where all you might see data science applications in, like in your day-to-day life. Now say the e-commerce industry. Now what are the different kinds of problems which they try to solve using data science in e-commerce is identifying customers, recommending products, analyzing reviews, so identifying consumers. So you might have often seen an email which says that you recently saw this particular X product, we would recommend you this Y product. So often you see that particular horizontal belt which comes under the Amazon products details that you have. So that is the recommendation product application that you see. Now, how are they recommending products to you? Now, this recommendation, like it is an application which comes completely under data science, and you have recommendation algorithms which aid you to come up with certain recommendations for a next product. Now, how is this done on an intuitive level, on a very simpler level is, say I am a particular user, ABC. Now, I might be similar to the other user, DEF, in certain properties. Now, these certain properties could be like very profile oriented, like it could depend on your complete profile, like the kind of profile you have. You might be staying closer, you might be in the same profession, etc., etc. So these are like some of the ways in which you're trying to recommend products. So I like this particular product, my friend like this product, and I have a third friend. So maybe Amazon might just recommend that third product, that particular product to my third friend. So that is just an example of recommending products and how it is done. Now you have analyzing reviews. So you have a lot of product reviews which you give on a particular Amazon product, right? Now these reviews are highly analyzed. They are analyzed by using text analytics, and they are analyzed by using text analytics algorithms. Now these are algorithms which are developed as a part of your data science framework, and they help you to analyze whether a particular product has a good vibe or a bad vibe, or say positive or a negative vibe. Now this is something which data science algorithms help you to do, and how it is being used into the industry today. And it's very deeply imbibed, as you can see in the e-commerce space, that this is something that everyone has seen, like the product recommendations, analyzing reviews, and how they do marketing to a certain consumer only. Like you might get a certain discount code, by your friend might not get. So it depends on how they analyze and how they figure out a particular profile is better suited for a certain discount code. Now, if you look at different problems in the manufacturing sector, like predicting potential problems, then maintenance scheduling, anomaly detection. So you'll just figure out like which particular machine might just die out soon or might just cause certain problems. So these are also just examples of the data science use cases that we have in the industry. Now, banking. Now, when you look at the banking sector totally, you'll see that fraud detection is a very, very important application which you might see. Whenever there is like a large number of customers which a bank has, and I have to say sanction certain loans to a certain section of users. Now, if I get 100 applications as a bank, I'm not going to be sanctioning all of them. So say I've just decided that I'm going to sanction, say, 50 applications. Now, how am I going to decide this? So this decision is basically taken with the help of past data about the customer. So you just look at what the customer is all about. Look at his transaction histories, look at what all activities he's done, whether he's paid the premium on time, whether he's paid the EMIs on time. You look at his different behaviors and then conclude whether this person would be a fraudulent customer or not. This is done using machine learning algorithms. And machine learning algorithms are, of course, a particular branch of data science, as we saw in the three bubbles in the last slide. So these are like some of the applications you'll see in the banking industry. Then secondly, you'll see healthcare, medical image analysis. Now, when you say that, the best example here would be like even the recent COVID time cases. So often when you're detected with like being a COVID positive patient, you are asked to do a CT scan. Now, when they do a CT scan, they look at the different images and they look at the patterns that you get from your lungs, and they label it as whether it is very severe or whether it's not severe. They do this with the help of data science algorithms, which go in the backend where they're doing some kind of image related problems, image recognition, image classification, many things which go into the medical image analysis space. Then you would have also seen self-driving cars. Everyone has heard about Tesla. So how is autonomous driving working with Tesla? That is happening with the help of data science algorithms and problems. So it is enabling you to do much better things in the world with the help of simple mathematical algorithms. Now, in finance, if you see algorithmic trading, anyone interested in the stock market would know about how algorithmic trading, like as the concept is and how it works. Now, how it actually works, it uses some kind of data science application at the back end, and it's trying to do some analysis and come up to a conclusion. So these are just some of the basic applications which you might see into this space. Now, how the life cycle functions is what we'll see here in this particular cycle that you see. So here there's a process flow, the process flow chart, which is going to be talking about the different phases through which a particular problem is assessed through. And this is the kind of pipeline which it follows when it is when it is the data science pipeline to be taken as a solution when you have a problem. So say like the first phase that you'll see, or the very first thing that you'll see is about the data science life cycle would be business understanding. That is, if you have a problem, you have a problem statement to solve, you will understand what the problem statement is all about. You will basically define what could be the different objectives for which this, by which you can solve this problem or how you can tackle it. Secondly, the second step would be data mining. That is, you need to figure out how to fetch the data. That is, if the data is readily available with you, you might just directly work with it, or else you might have to procure the data. That is, get it from some third-party source or wherever possible. Now, the third step is data cleaning. So the data that you will get is not going to be clean. it's not going to be in the desired format that can be fed into a particular algorithm. So what you'll need to do is maybe you'll just have to figure out ways to replace values or let the values which are not filled, like um you might just have some blank spaces or something. You'll have to figure out how to place those like blank data in with respect to the entire data and how to impute it basically. Then the next step would be data exploration. So when you say data exploration, here comes all your pictorial representations and graphs where you will try to do some kind of number crunching to understand what the data is trying to tell you. Next up is going to be feature engineering, where you might just create different understandings out of whatever data you have and try to create new domain specific or new problem specific columns that will help you to understand the data better and which will help you to give better predictions or better solutions to the problem that you're trying to solve. Next up would be predictive modeling. So predictive modeling is the step where you're going to be performing machine learning algorithms, evaluate the performance, see how your particular algorithm is working out with your data. Next is your data visualization, which is once you have your model ready, that is you're going to be solving this X problem by applying this X algorithm. Algorithm is basically a set of steps for people who are not aware about it. It is just a series of steps that you perform. They could be mathematical or they could be conditional, depending on what kind of a algorithm you're trying to develop. So back to your data science life cycle. So the next step is your data visualization. So once you have your algorithm ready on applying like whatever data you have, you go to the data visualization step where you're going to be communicating whatever your findings are or whatever your conclusions are to the people in your working organization, and you present that to them via some graphs, charts, some reporting methods so that it is easily understood. So these are the basic steps which are followed as a part of the data science life cycle. Now the business understanding, of course, you need to ask the right questions. It is very much similar to your software development life cycle, requirement gathering basically, to understand what the problem is, to get more information about the problem through your business stakeholders. Then you also set the objectives once your business problem is well understood. Next step is to procure data. Now, you might have data sources which are already internally existing within the company, or it might be external. It might be lying with some third-party stakeholder or some third-party data service provider. So you need to do the extraction. So if you have some internal database, then you will just query that data by using SQL, which is a major structured query language method, which helps you to extract data in a much more simpler way in the form of a table, basically, so that it is much more readable and understandable. If you have large unstructured data where the data is not present in a tabular format, then you might want to use Hadoop or Spark, which are technologies which enable you to fetch large amounts of data in a much more efficient manner. Then if there is some kind of external data, then you might want to do some kind of web scraping, some kind of data conversion. You might need to purchase some software, purchase some license to get access to that data. That is what data mining is all about. Next step is data cleaning. So as I spoke about handling missing values, like if you have some blank spaces or something in your data, then how would you treat that? That is a part of your data cleaning process. Next is your data exploration. So first of all, you'll just form some kind of a hypothesis to test the data. Once your hypothesis is formed, you will try to identify and understand the patterns. There could be different data types, like there could be some numerical data type there. That is, there would be some kind of numbers which are present. Then the next thing is categorical data. Like categorical data example would be something like gender. Say there is some kind of a male and female kind of a value in the categorical data. Then there are different tools used to analyze this data, which could be correlation plot, pair plot, histograms, scatter plots, bar charts. These are some graphical representations which can be used to understand how the data is structured, basically. Then we were talking about feature engineering. So in terms of feature engineering, you might want to create a new column which is helpful to understand the data better. So say suppose you've been given a person's date of birth as one of the columns. Now you can create another feature which is called as age. You can calculate that by subtracting the date of birth with today's date, and that is how you'll get the age of the person, right? So that's one way to do feature engineering, which will help you to get a better understanding. Then, of course, your next step is going to be predictive modeling, where we're going to be using different kinds of models. So there is a wide arena of models which are available in the entire algorithm space. So you have regression algorithms, you have classification algorithms, clustering algorithms, and also reinforcement learning. So regression algorithms basically help you to predict continuous values. Say suppose, for example, I want to predict tomorrow's weather. What is going to be the weather in a certain part of the country? Then I will look at its historical data. That is, I will look at the temperatures in the past 10 days, or say past year, or past 5 years, past 10 years, and then I will use linear regression on as an algorithm on that data and help you to predict basically the continuous value. So basically your weather is a continuous value, right? It could be anything. There is no definite value to it. It could be any temperature also. Now, when you talk about classification algorithm, you have defined categories under which you're trying to solve a particular problem. So when you talk about classification algorithms, there are defined categories in it. That is, say, whether a person will be allocated a loan or not. Yes or no. So there are two categories, right? Yes or no. So it's a binary problem. Binary in the sense two classes. So it has two categories here. Yes or no. So that's how you get like two definite classes. So you can solve those kind of problems by using classification algorithms. Then you have clustering algorithms. Now, these clustering algorithms are majorly targeted towards marketing problems. Like if you want to understand or group together different categories of people, then you can do that using clustering. Say, I just want to find out similar people to my profile. Then how will I do that? I will group all the people who I have, like whose data I have, into different groups. Now, clustering basically helps you to get those clusters in place, and it also helps you to market the right kind of campaigns to the right kind of people. So clustering is also highly used as a algorithm or as a problem solving technique in data science. Then for data visualization, we have different tools which can be used for data visualization, which could be like different softwares like Tableau, ClickView, Power BI. Then you also have different libraries which are also existing in Python and R, which are the major tool headers in data science. Like they are the best tools for solving any kind of a data science problem. So you have different libraries like Matplotlib, Seaborn, ggplot2, deployer. So these are the different ways in which you can do data visualization even through your programming language. So this is just like an example of the kind of a dashboard or a kind of a pictorial representation of the different graphs which can be created from the data itself to understand how your data is structured, what kind of insights you can generate from the data. This is like a regular dashboard picture which you have from Power BI. So this is what you can use to create different things. So there are tools which help you or enable you to create much smarter technological representations of your data and easier representations to understand the data in a better way. So I'm just taking a sample use case so that you get a basic idea. So I just want to decide whether I'm going to give this X person, like whether I'm going to provide this person a loan or not. So what kind of a data I would have with this problem statement that I have. So this is my use case. That is, I have to design a system which will enable me to decide whether I can provide a loan to you or not. Now, what is the data that I can have with a certain person? Now we'll start from the left of the user, that is the general information: name, profession, organization, education, age, origin, society, city. Sorry. So these are the places, like the basic demographic details of a particular user. Then you'll have like the school details about the person. Like this is like a possibility: age, test score, academic performance, interview performance, etc. There could be information about the retail store which is associated with a certain person, number of visits that a person visits in a month, revenue, category of products that he buys, how his response has been to the promotions, and the level of satisfaction he has. Then about the insurance premium also, like what is his age, what are the dependents on him, what is the kind of medical history, test reports, smoker, non-smoker. Then job application, say experience the person has, expertise, what kind of projects the person has worked in, interview performance, and stability. Then when we are trying to solve a particular bank loan problem, then you'll have credit history, what kind of transactions the person has done, what is his income, what are his existing loans, what is the amount of those existing loans, what is the balance that he carries forward every year, what is his behavior with respect to financial instruments. So these are just some of the examples of the data points that we have with a particular user. Now, how should we approach this problem? So should the customer be given a loan or not? So basically, it's a yes or a no problem. So it falls under the classification category. So it's a classification problem. You might do some kind of feature engineering on it. That is, you might just derive some kind of a credit score associated with it. So every person has a credit score associated with this profile. So that is calculated with respect to whatever formula is followed by the bank. Then you will just integrate all the different data sources you have. You will get onto the next step, which will be feature scaling, wherein you are trying to normalize the data so that all the data falls into the same sector or under the same pattern, basically under the same graph. Then you go to the next step, which is model building, wherein you're doing some kind of predictive modeling, wherein you're trying to build an algorithm which will help you to determine whether this customer is going, like is the ideal candidate to be sanctioned a loan at this point or not. Then you make predictions, that is, you decide whether the algorithm decides whether the customer will be given a loan or not. So this is like the simplest approach that you can take to, solve a certain data science problem which you might come across in the industry, and which is a very classical problem in the banks also. So I've spoken about data science at length. Now I'll just give you like a brief idea about what you can do as like being into the education sector yet, like if you've not gone into the industry already, or if you're in the industry and if you're planning to switch to the data science stream, then today if you see, it is the most sought out career in India. You need to just get your hands full with different kinds of technologies which are there, which is machine learning, artificial intelligence, natural language processing, IoT, etc. The basic thing is you need to get your basics clear. That is, your fundamentals have to be very clear in your head. That is what will enable you to solve complex problems. And then it will help you to develop new technology to simplify human work, basically. So you will be enabled with the help of the different technologies to come up with very efficient solutions to this particular problem. So it will help you to come to a better space, basically. So you have different ways about getting into this field. I can answer those questions like one-on-one if there are any questions of that sort. But yeah, this is what I wanted to talk about today, majorly about the data space and what actually happens in data analytics and data science. So this is like a brief introduction to people who are not aware about this particular space and the new buzzwords where people say that this is the most interesting job or the most sought after roles today in the industry. So I'm just going to open the floor to any kind of question and answers that you have, so that I can answer maximum questions which you would have, and try to get like a better understanding of your questions that you would have. Yeah, I'm seeing that it's blinking. I'm just going to stop sharing this and then we can go ahead and answer all the questions. Ma'am, can you show the business understanding slide again? Hi, Gitanjali. What is exactly the question that you would want to understand? Like, what is it that was doubtful to you, or something that you would want me to answer? Hello, are you able to hear me? Okay. What would you want to understand on the business understanding part? I will share that thing again, but so it basically emphasizes on learning and investigating the problem to develop context and understanding, and also to ask the right question to gain a deeper understanding, and also to set the objectives. So say in our example where we are deciding whether a customer should be granted a loan or not, what we're trying to do is you learn and investigate what kind of a data is already present with the bank, what kind of behavior the users are depicting. Ask the right questions to the business stakeholders. That is, ask your managers the right questions. That is, what is the different kind of data that we can incorporate into a model to develop a much more robust and a fast-paced model, which will enable you to make a decision quickly. Once you have the answers to those questions, you set the objectives. Okay, that this is the data that I'm going to be taking, this is the kind of model I'm going to be building, and then I will make predictions on this, on the basis of which the data driven decisions can be taken on the basis of that. So basically you look at data and then you take a decision. So those are basically referred to as data driven decision, and this is how it will help you to understand them. I hope this is clear now, Gitanjali. Anyone has any other questions, guys? The floor is open to any kind of questions that you would have. Okay, you guys are putting it on chat only. Okay. Who asks this? Okay, Manohar is asking from where to start the journey of data science. Is it from ML or deep learning? So the basic question is, are you like already aware about how to program? So once you have a basic understanding of one of the programming languages, be it say Python or R, then you can go on to learning your basic stats, then go on to ML, then go to DL. So that is the usual graph that you follow. So you should be first of all aware about how you can do some kind of programming, and also that you have some kind of a knowledge of basic statistics and basic mathematics. So that is the usual hierarchy that you follow once you try to delve deeper into the much more technological things with respect to data science. How? Okay, Gitanjali asks, I hope, okay, you start, okay, just one second. Manohar said that I've started with ML. Okay, that's fine. If you are like aware about the prerequisites which are required, you can jump onto ML, no problem with that. Gitanjali is asking me, how will we know if the data is accurate or our prediction is correct? How can we be sure that everything is accurate? So yes, when we are trying to make predictions on any kind of a data, then your predictions are not going to be 100% correct. Of course, there will always be, yes, there is always a small glitch. So you're trying to make predictions closer to the actual one. So you are trying to just basically minimize the error. So when you see, say, weather prediction, are we able to predict the weather for tomorrow correctly? No, right? Okay, just say, for example, just think about a certain time where the state has released a warning saying that kal barish hone wali hai, tomorrow it's gonna rain. Now, does it happen always that it rains? It doesn't, right? It happens sometimes, it does not happen. So that is because of the glitch, or basically the kind of error, the kind of error which the model generates, and it's a problem. And it is always going to stay. But what we are trying to do is trying to get as close as possible to the actual thing that would happen. Okay. Tanmay asks, ma'am, data cleaning is the most frustrating part and time consuming part of data analysis. How should someone do data cleaning so it takes less time? Some broad strategies. Okay, so data cleaning is always the most time consuming tasks, and you really cannot do much about it. There's like barely anything that you can do with it. You will always have to spend time on that. Like, you can't escape that at all. You will do, like, you might just develop a code which can run faster, but you cannot do things in a fraction of a second, right? When your data is large, it is always going to take time. So always consider that you will have some time to be spent in data cleaning. Always, there is no escape from that, frankly speaking. I have okay, so someone who says, sorry if I miss any question. I have problem with practice of ML problem. Can you suggest practice strategy and how to go deeper into ML, please? So practice problems are something that you can pick up even on Kaggle, for that matter. So you can pick up Kaggle problem statements, or some problem statements which are there on Coursera or anywhere on Udemy, that will help you to get a better understanding about the problem statement. And then deeper into ML is basically you trying to understand, you just trying to get the best out of it. That is, you trying to understand like the entire algorithm step by step. Like, if you're able to explain mathematically what a particular algorithm does step by step, that is where you are. That is the right place where you are. Like, if you understood that much, that's it. That much is only required to get a good understanding and how to solve problems, basically. Okay, I hope that answers your question. Gitanjali asks, cookies are related to data, right? Yes. Are we allowed to take data from the user without their consent? Is it okay sometimes being a data scientist? Yeah, so that's like a trade-off that you have in this particular field, where you do take data from the user without their consent as such. So it's not
Is it unethical?
not without consent. So when you actually install a particular application, they ask you a set of certain questions, right? Yes, no, yes, no. So when they ask you those questions and you say yes for everything, then you are just giving them default permission, right, to capture any kind of data. So yes, you are giving certain kind of permission. But yes, there is this a data breach that is always happening in terms of privacy and all. But you cannot do much about it, really.
But
That
isn't
is
it?
how data is collected, and that's how the world is running, basically. So even if you might have a view on it, you really cannot do a lot in avoiding it or anything of that kind. So it's gonna stay that way. So I'm
But
sorry.
won't it be unethical?
Question is, ma'am, can you please
Hello,
tell us
ma'am.
about your journey into this field? Okay.
Ma'am?
So I have been into this, like how I can just talk about how I landed up into data science. So I am an engineer. Basically, I am an IT engineer, and I completed my BTech in IT. And after that, basically, I worked for 2 years, and I worked with an investment bank, and I worked as a software developer. So I was already aware about the software technologies. So I was aware on the computer science bubble entirely. What I didn't know was more about the machine learning side. So I have done a master's in data science from NMIMS, and that's where I got my basic understanding about all the data science technologies that you have, be it machine learning, be it AI, be it text analytics, everything. And that is basically the place where I got to experiment and work around with different data, and also get acquainted with the different problems that come across. So a master's really helped me in that way. But that is not very necessary. It's just a mandate for some companies, but not for all. So that is how I got into the space, and that's how I'm working as a data scientist at Viacom 18, basically. Gitanjali asks, isn't it unethical? Do we have such rules being a data scientist? Like, what are we allowed to do and what are we not allowed to do? No, there are no such rules. It depends on organization to organization. There's a lot of data being picked up, but there are no rules that you can use, you cannot use this. Whatever data is there, you can use everything. Tanmay asks, which is preferred today between R and Python? R is used largely for financial problems, solving financial problems, whereas Python is used highly for solving any kind of a problem. So when you want to apply, say, deep learning, or when you want to say apply text analytics, Python has libraries already implemented which will enable you to solve those problems easily. So that is one way of putting it. That R and Python have different use cases. Python is used a lot more than R because of its application. There is no preference as such. Both are equally important and depends on the problem statement that you're trying to solve. One is more important than the other, basically. What is big data and data adapter? Okay. Who's this? Someone asks me, what is big data and data adapter? So basically, big data is a technology to which allows you basically to read large amount of data in a simpler fashion, or basically something that will allow you to crunch data or read it in a structured way, even though the data might be in GBs or DBs. So basically, big data is handling large data with the help of certain technologies in the simplest. Gitanjali asks, is there a right way or a proper way to learn data science? Any suggestions? How could we learn it well? There are multiple ways. One is a proper like a master's course or something that you take up, which defines the course structure. The second way is take up some kind of a certification in data science, which gives you the path. The third way is, of course, to go through the entire hierarchy. That is, you obviously do have a lot of free resources also available, but how you can get ahead with these free resources is also a different thing. So go up the hierarchy, that is, start from your programming languages and go to your maths, get your basics cleared, then go to ML, then go to TL, then go to AI, reinforcement learning, etc. Too many things to learn. So that is one way of, there are multiple ways. So you could choose any path. If you do not want to take the hassle of doing things on your own, then might as well take up a course which will define your own path. Saksham asks, as an ML engineer, is the role primarily focused on just model development or just like SD is? There is also deployment part of the job description. Depends on role to role. So it is highly subjective. It depends on organization. What kind of a role are you involved in? But technically, as in, like, if you talk about ML engineer, then deployment should also be a part of it. But depends on organization to organization. They might have that as a part of it, or they might not. Totally depends. I think I have answered all the questions which came across in the chat window. Do you guys have any other questions? Yes, no. If you were hiring someone for a DS position, what would you specifically look for? Especially because Python and other similar buzzwords are uniform in most CVs. So when we try to hire data scientists, we try to look at how clear the basics or fundamentals are, whether the person is able to write a simple code or not. That is very important. So that is one aspect. Secondly, also about his understanding on the ML algorithm. So whether the basics are clear or not. So there are questions around all the algorithms, like how the mathematical part of it is structured and everything. So that gives like a basic understanding on whether the person is adaptable, whether he knows or whether he doesn't know stuff. So that is one way of like analyzing whether a person is suitable for a data scientist role or not. So that is what we try to check. In terms of CVs, yes, CVs, you need to have Python, R, and all of that. Definitely. No escape to that. Can you share this PPT? Yes, of course, I can share this PPT. I'll share this across with you guys. Like after this call, I'll share it across an email and people will send it to you. Okay. Does that work? Cool. I think we are done with questions. Anyone having any other question? Okay, finally, were there any specific resources that are useful for this interview preparation? Just like there is lead code for SE, is there anything similar? You can use Analytics Vidya, you can use Kaggle, you can use HackerEarth. What else is there? These are some of the platforms which I am very much aware of. So HackerEarth, Analytics Vidya, very good, and Kaggle, good enough for understanding what kind of, not for interview prep, but for your profile prep, basically. Analytics Vidya has a lot of interview prep content too. Which is better language, Python? No, both are good. Both are good enough. So you can use both of them, but they are designed specifically for different applications. Both are equally needed. Okay, I think we are done with questions, Harshita. So
Okay.
can we?
Yeah, thank you so much, ma'am, for joining us today. That was a really informative session. I hope the
Harshita, we can't
students.
hear you.
Um, just a second. Can you hear me now, ma'am? Hello, hello, ma'am. Am I audible?
Ma'am, you are actually audible. I don't think
Oh, okay.
you're audible to us. I don't know if you're audible to Ekta ma'am.
I guess I'm not audible to her. Ekta ma'am, can you hear me? No. Okay, just a second.
You can unmute yourself and try maybe.
Hello, ma'am. Can you hear me? No,
Anyone can
ma'am.
hear her?
Yeah, others can hear. So Ekta ma'am is not able to hear me, so I'll just
Able to
end
hear
it
you
like
now.
this.
I'm able to hear
Okay.
you. Yeah.
Okay. Thank you so much, ma'am. Firstly, that was a really informative session. Okay, and thank you so much for joining us here today and taking the time for this webinar. I
No
wish you
problem.
had a good day.
Yeah. Thank you.
Okay, and all the students, I wish you had a good insight of the topic and all your doubts were cleared. So I'll just share a WhatsApp group with you all. We are gonna organize some more free webinars, so you can join us there. Tomorrow we'll be having a webinar on cybersecurity. Okay, the link will be shared in that group itself, so you can join us. And thank you so much. That's it for the day. Have a good day, everyone. And once again, thank you so much, Ekta ma'am.